This is a short video on how we use the ionic product of water to determine the concentration of hydroniums, or perhaps you might need to determine the concentration of your hydroxides. Good news, the ionic product of water is given to you on your resource sheet. It's this one here, where Kw is the water dissociation, so hence the ionic product of water. And it is the hydronium concentration times the hydroxide concentration, and it always equals this 1 times 10 to negative 14. It's a constant at 25 degrees Celsius. Now it is temperature dependent, so if you increase the temperature you will alter the equilibrium, which means you will actually alter this value. You won't get assessed on that, but just to know that it is temperature dependent, as is all equilibrium reactions. So in the SciPad on page 276, they give you the dissociation of water. So water is constantly dissociating, but to a very small extent. The concentration of the hydroniums is actually very small at 1 times 10 to the negative 7. The concentration of the hydroxides is also the same value, 1 times 10 to the negative 7, because for every water that dissociates, you produce 1 hydronium, you produce 1 hydroxide. So it's natural and logical that these would have the same concentration. If you were to write out the equilibrium expression or constant, products over reactants, remember we don't put water into an equilibrium expression, which is what it says down here. Water is so large, that's the concentration, that we remove it, okay, compared to the very small concentrations of the hydroniums and hydroxides, which is why it's left out. So this here is the ionic product of water expression, and it's very useful when we need to manipulate and find the amount of hydroxides when you already know hydroniums, or vice versa. So we will not need to memorize this, but what it does give us is this equilibrium expression that is on the resource sheet. So how you rearrange the equation: if you have got your hydroxide value but you need your hydroniums, then it's a simple case of using 1 times 10 to the negative 14. Okay, so you use this value for Kw and divide it by whatever your hydroxide value is. On the other hand, if you have got your hydroniums and you need your hydroxides, then you use your expression 1 times 10 to the negative 14 and divide it by the hydroniums. It's a very useful tool and technique, so to ensure that you are capable of using it, please complete page 276, and I'll see you in the next video.